Everyone in general has an idea of how changes in one variable cause changes in the other variable. For example, increase in the age of a child mostly is accompanied by change in the weight. Similarly, increase in the study hour mostly results in percentage increase in the marks. But for precise understanding and in-depth analysis, let's take an example of riding in a cab where the distance and the fare, these are the two quantities, and we will investigate the relation between these two quantities. How the fare changes when the distance from the origin changes. Let's consider that the base fare is $5. So if the base fare is, let's say it's $6, 6.00, and per kilometer charge is equal to $2. Means that every kilometer you travel, there will be additional charge of $2. So let's say that this is origin. Let's mark this as point A and let's mark this as point B. If this segment represents 1 kilometer here, what would be the fare here? $6 plus $2, that will make it $8. Another kilometer, this would be at distance of 2 kilometers, the fare would become $10, and at distance of 3 kilometers it will become $12. At distance of 4 kilometers it will become $14, and at 5 it will become $16, and of course at 6 kilometers it would become $18. And here it was, the distance was 0 and the base fare would be charged only, and that was $6. Now we have this information. If we want to plot this information in the form of table, we should name these two quantities. One at the bottom here, this quantity, this is representing the distances from the origin, from your home. Here this is 0 kilometer, 1 kilometer, 2 kilometer, 3. So let's call this distance as D for distance. And this quantity on the upper side of the line, that is the amount of fare, and its units are dollars. So let's call this as F for fare, and let's get started and input the values 0, 1, 2, 3. Those are the, okay, for 0, how much is the fare? For 0, the fare is $6. So for 1, this is 8. For 2, it's 10. For 3, it's 12. For 4, it's 14. For 5, it's 16. For 6, it's 18. And for, but that's how we can continue doing this. Now this is the tabular representation. That's how we can represent the data in the tabular form. At 0 it's 6, 1 at 8, 2 at 10, 3 is 12, 4 is 14, 5 is 16, and 6 is 18. Now the fare depends upon the distance. So fare is in fact called the dependent quantity, and distance, which doesn't depend on anything, that just depends on our own will, how far we want to go, that distance is called an independent quantity, because distance doesn't depend upon fare, but the fare actually depends upon the distance. This identification is very important because the independent variable, this independent variable, that's always is going to be plotted along the x-axis, and the dependent variable is always going to be plotted along the y-axis. So here this is our x-axis and this is our y-axis. Now we can start plotting distance along the x-axis. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Of course this is 0 at the origin. And now if we start from 0 fare here, then keep 2, so this would be 2, this would be 4, this would be 6, this would be 8, this would be 10, this would be 12, and this would be 14. We don't have to plot all of the points, just few points are good enough. For 0, that's 6, so the first point is going to be right here. So make it a point. 0, 6. Where is the next point? 1, 8. So for 1, it's going to be 8. This point is going to be right here. And for 2, it's going to be 10. For 2, it's going to be right here. That's 10 here. And for 3, it's going to be 12. That's right here. And for 4, it's 14. That is going to be here. I wish we had a bigger graph paper, but that's fine. We just need few points. And now we can see if we draw the line through these points, this is going to be a straight line. And we can in fact extend this straight line on either side. So the entire data is now being represented by this straight line. And what if we want to find out what the equation would be? The equation fare is going to be equal to, fare is in fact equal to the initial fare. What was the initial fare? That was $6 plus rise over run. If you identify any 2 points, and if one small scale along x-axis is representing 1 kilometer, and this, how much is rise? That's one small scale along y-axis is representing $2. So what is rise over run? That is 2 over 1. Rise over run, that is 2 over 1 time whatever the quantity is on the horizontal side. What was that distance? So that is distance. And now because the fare was being represented by f, this is equal to 6 plus rise over run is 2 over 1, which is again 2, time what is distance was represented by d. So this is f is equal to 6 plus 2d. This could be equation, and we can find, by using this equation, we can find the distance, and we can find the fare for any given distance. Suppose if we want to calculate the fare for 50 kilometer, we just substitute in this equation 50 kilometer and we will find out what the fare would be. That will be covered in the next video.